Friends, welcome to my channel Civil Cap, and previously we have studied the three moment equation. Today in this class we'll deal with numericals related with three moment equation. So let's get started. Now we'll study the second numerical related with three moment equation. So here a continuous beam is given with two beams and three supports. In the first beam it is loaded with UDL, and in the second beam it is loaded with a point load at a distance of 2 meter from end C, and moment of inertia for the first beam is given I, and for the second beam it is given 2I, and the length of first beam is 4 meter and the total length of second beam is 6 meter. So here the question is to analyze the continuous two span beam using three moment equation. Our first step is to draw the free body diagram for the given equation. So the free body diagram for the given equation will be parabola, as it is loaded with UDL of the first beam, and in the second beam, as it is loaded with a point load, it will be a triangle which will not be equilateral, as the load is not loaded at the center of the beam, and it is 2 meter distance from the end C. Therefore the CG will not be at the center. After completion of first step, we will find the area of the parabola and the triangle. First of all, let us find the distance of this triangle from the end C. That is, we'll use formula of distance of CG from end C as B plus L by 3. This is the formula we'll use to find out the CG of this triangle from end C, this value, as this formula is simple mathematical formula. So now we'll define a and small b, as let this distance be a and this distance be small b, and the total length be L2. Hence I'll take value of a as 6 minus 2, that is 4 meter, and the given b value will be 2 meter. Now I'll put this value of b in this equation, that is 2 plus the value of L is 6 meter upon 3. So this will be now equal to 8 by 3 meter. This is the value of the distance of CG from end C, which is the value of small a2. Again, here if I find the value of a1, as this is a parabola, so its value will be simple, that is L by 2, which will be equal to 4 by 2, that will be equal to 2 meter. So I have found the value of a2 and the value of small a1. As discussed in previous numerical, our first step is to find the free moment diagram for the span AB, that is AB. So I'll find the maximum ordinate value for the beam AB, which will be WL square by 8, as discussed in the previous video. So here the W value is equals to 20 kilonewton per meter and value of L is 4 meter. I'll put these values in this equation, which will give me a result of 40 kilonewton meter at midspan. Similarly, I'll find out the maximum ordinate value for the beam BC, as I can see that here a point load is acting, or I can say unequal triangle has been drawn by me for a point load then in such case the value of maximum ordinate for the triangle produced will be WAB upon L. Here, as I have previously discussed, the value of A and B. So my value of W is given, that is load value, that is 30 kilo Newton. Now my value will be 30 into 4 into 2 upon 6, which will give me a value of 40 kilonewton meter. As I can label the value of the maximum ordinate on the parabola, that is 40 kilonewton meter, and what I have got for the beam 2, that is the maximum value is 40 kilonewton meter. And now I will find the value of area for the beam AB and A2, that is for this triangle. So I will find the area A1, as I know the area of the parabola will be given by formula 2 by 3 into L into H, that is equals to 2 by 3 into L. L is 4 meter for the first beam, and height is the value of the maximum ordinate, that will be equal to 40. So here I will get 106.67. Again I'll find the area of A2, that is the area of this triangle. So as we know that the area of triangle is equals to half B into H, so here it will be equal to half, base will be equal to length of the beam, that is equals to 6 meter, and again the height is the value of the maximum ordinate, which will be equal to 40. So my value will now be equal to 120. In this way we can find out the area. Hence my findings from the question has been completed. Now I'll put all the values in three moment equation. So as I know, the three moment equation is MA L1 upon I1 plus 2 MB L1 I1 plus L2 I2 plus MC L2 I2 is equals to minus 6 capital A1 small a1 upon I1 L1 minus 6 capital A2 small a2 I2 upon L2 plus 6 EHA upon L1 plus 6 EHC upon L2. All the values I have discussed in the previous video. Those students who are new to this video can refer my previous video for three moment equation and its applications. So here, as we know that in simply supported beam the end moments are equals to 0. So here my values of MA and MC will be equal to 0, and I will get the value of MB. So here I will put MA and MC value equals to 0. Now what all values I have found above, I will put in the three moment equation. That is, the value of MA, or this portion will be equal to 0, as MA is equals to 0, and L1 will be equal to 4 meter and L2 will be equal to 6 meter as given in question. So I'll put these values here, and the value of I1 will be equal to I plus L2 will be equal to 6, and as per given question the value of I2 will be 2I plus MC will be equal to 0, as it is the end support. So this complete value will be equal to 0. Again here minus 6. Now we have find out the value of A1 equals to 106.67 multiplied by small a1, that is the value of A1, that is the distance of CG from the end A, equals to 2 meter. Now I1 as specified will be equal to I, and L1 will be equal to 4 meter. Again negative 6 A2, what I found 120 meter square multiplied by the value of the distance of the CG from the end C will be 8 by 3, as we have found out previously it will be equal to 8 by 3. 2i as specified in the question, and L2 will now be equal to 6 meter. As in question there was no specification regarding the sinking of support A and C, hence these values, that is HA and HC, will be equal to 0. HA and HC both will be equal to 0, hence this both the part will now be equal to 0. So I will get the value as 2 MB 4 upon I plus 6 upon 2i equals to negative 6 into 106.67 multiplied by 2, 4i, minus 6 into 120 into 8 by 3 upon 2i into 6. Now after simplifying, I'll get the value of MB equals to negative 34.286 kilonewton meter. So in this way we'll come to the solution of this numerical. Now our last step is to draw the free bending moment diagram. Now I'll draw the bending moment diagram for the numerical we have solved. So previously, as we know that the value will be parabola and a triangle what we have drawn for the free body diagram for the given loads having maximum ordinates as 40 kilonewton meter for both the values. Now what we have got, the value of MB is negative 34.286. Let me mark it here somewhere, and we know that the moment at A and moment at point C are equal to 0. Now using these 3 points I will draw my bending moment diagram and label it with 34.286. The value what I have got and marking in red color will be in negative, and the values what are left here or previously drawn are in positive. So this will be the final bending moment for my numerical. So we end up our video here with this numerical. If you really like my video, then subscribe, share and do comment if you have any doubts in my video. So thank you for today.